right? So rotation and torque. So this is driver. And then this one over here, right, is the rotation direction and torque for the driven, okay, gear. Okay. Now I'm going to draw in orange, right? The one in orange that I'm going to draw now, okay, I'm going to draw in orange now. This is the force, right? Okay, there's the force generated by the driver gear. Okay. Now, the driven is going to cause a resistance. Yes or no? The driven gear, right? The driven gear. No, very important to notice this. Okay, if you don't see this, we are being big duda. Okay, so the driven gear is generating a resistance. Yes or no? Right? It can be a load, for example. Okay, example, a load, okay, or attach to a pulley system to lift a heavy weight. For example, now question for you, if the driver force as what I've drawn is going towards the right, right, for the driver, okay, for the driver, can you tell me the driven gear, which direction will it be heading for the driven? Is it going to follow the driver gear or is it going to be opposed? Anyone? So there's only the two of you. Yep.
The same.
Huh?
The same.
The same direction?
Yeah. Actually,
Yeah.
wait.
Yeah,
Yeah.
but you be careful, you know. What did I just say? The driver gear is always generating a what?
Resistance.
Exactly. Right? So no doubt the rotation, sorry, there's no torque down here, okay? The torque is not this direction, okay? The rotation of the driven gear, right? So the torque is in which direction? Rajinder, I think you're almost getting it.
The torque is clockwise. No, counterclockwise. Sorry, counterclockwise.
No, it's either left or right, okay? So this is the direction.
Oh, okay. Okay.
Okay, so this is the resistance force of the driven gear, right? It cannot be in the same direction because if it's the same direction, means the load is helping the motor. Does that make sense? If I'm going to put it in green, Okay, if we say that the driven is in this direction, means what? The motor or the gear A is helping the motor, yes or no? Which does not make sense. You have to get this concept right. Okay. Hello.
The net force would still be in the other direction, right?
Yeah. I mean the net force is depend on the where sorry, the net force, the summation of the net force will be equal to 0. Okay. Later on you will see this. Okay. Later on you will see this. If we say that the driven, okay, the driven gear is generating a force following the driver, what we are saying means the driven gear is helping the motor, right? So when you drive, right, the road create the resistance, and when you accelerate, right, the road is opposing the what? The torque induced by your engine, yes or no, right? By your motor or your electric motor, as you can say now, right? So you have to get this concept right. Identifying the right driver direction of the force and the driven is ever so critical. Okay, if this is wrong, okay, we are like game over. Okay, why? Because if the force is wrong, right, your moment will be wrong. That's where the trouble comes. Right, your moment direction will be wrong. Okay, so sometimes when it's positive, it goes negative. Now, the complication of shaft design is this. Okay, this is where a lot of engineers, not just engineer to be like you guys, okay, but engineers make a very common mistake in this aspect. Okay, and I don't want you to make that mistake. Okay, and this is the easiest way to identify which is the direction. So this is wrong. Okay, so this is not the driver direction or driven direction. Okay, so we are going to do an example. Okay, this example is pretty lengthy. Okay, this example because of sorry, it's not difficult, but it's lengthy. Okay, it's not difficult, it's lengthy. Okay, so as I said, in the entire engineering discipline, it's only mechanical engineers are designing shaft. Okay, civil engineers, they don't design shaft. Material science sometimes, but anything with gears, like it or not, it is us. Okay, I wonder in the electric car, is there gear? No, there's no gear, but don't worry. Okay, gears are here to stay. Right, let's look at our problem. Okay, example 1. Okay, so and there are a few formulas that you all have to like remember, not remember, but take note. Okay, so I'm going to okay, here we go. So what you can see down here, right, is that we have a solid shaft AB rotating at 480 RPM and transmitting 30 kilowatt. Okay. So from the motor, okay. All right. So the motor, right. So motor, right. So motor, okay, motor. So we're given a motor. So we know that the RPM and input is at 480 revolution per minute, and the power input into the system is running at 30 kilowatt. Okay. Then it states that, and then they are connected to gear G, right? And then gear H. So this is gear G, gear H, and the motor is connected by the side down here. Okay. So 20 kilowatt is taken off of gear G. Okay. So we know that P out, right, at gear G, right, the power out at gear G is 20 kilowatt, and the power out at gear H is at 10 kilowatt. Okay. So we are also given that the allowable shear, right, is 50 times 10 to the 6 Pascal. Okay, so we know that now. Okay, so we also realize that no axial load. Okay, 0 axial load is applied on the shaft. Okay, so this is a system integration problem. Okay, because what we are going to calculate, right? We can calculate the diameter of the shaft, and likewise we can also calculate the selection of bearings, which I will not do in this class, by the way. Okay, I'm not going to have you do selection of bearings. Okay, selection of bearings you will learn in 3E05 after this course. Okay, or maybe 2D03. Maybe you'll learn that in 2D03. Okay. Okay. So first of all, we have to draw our transformation. Okay, we have to draw our transformation. So our transformation is, so this is my X. Okay, and then I decide to call this our Y and our Z. Okay, so we are going to take note. Okay, we're going to take note on the contact. Okay, take note, not on the, hold on. We're going to take note. Now this diagram you can find on Avenue to Learn. I posted it. Okay, we're going to take note of the contact point of the adjacent gears. Okay, so what do I mean by that? What do I mean by we're going to take note? I'm going to copy this. Okay, I'm going to make it small so you can see. So what do I mean by this term? Okay, take note. Okay, so I want you to realize where the contact points are. Excuse me. Yeah, we're going to take note of where the contact points are. Okay, that is so ever important. Okay, I think did I make a mistake regarding, yeah, it's 50. Sorry, I thought I made a mistake. So we're going to look where the contact point are. So from here we know that the contact point is at the top, and this one is at the side. Can you all see that? I've just put down in black. Okay, so you all have to take note of that. Okay, so I'm going to write down the things that you need to know. Okay, the process that you need to know. Okay,